What is time? We measure it, manage it, and feel it passing, but its true nature remains one of the universe's greatest mysteries. Is time a fundamental property of reality, or just a mental construct to make sense of change? Today we'll journey through 10 fascinating theories about time, some intuitive, others mind-bending. We'll visit Einstein's spacetime, quantum puzzles, and even question if the past and future are as real as this moment. As we explore, consider your own experience. Does time speed up when you're having fun, or slow down when you're bored? By the end, you might never look at your watch the same way again. Let's begin our voyage into the mysteries of time. Our journey starts with Albert Einstein, who shattered the old view of time as a universal, relentless clock. Einstein's relativity showed that space and time are woven together into a four-dimensional fabric spacetime. Picture spacetime as a giant trampoline. Place a heavy ball on it, massive objects like planets curve this fabric, and that's what we feel as gravity. Gravity isn't a force pulling us down, it's the shape of space-time guiding our motion. Here's the twist: this warping affects not just space, but time itself. The stronger the gravity, the slower time passes. This isn't just theory. GPS satellites tick faster than clocks on Earth, and engineers must correct for this. Time flows at different rates across the universe. Near a black hole, time slows dramatically compared to Earth. Your age, the duration of a moment, it all depends on where you are and how fast you're moving. Time is not a universal metronome, it's a local river, speeding up or slowing down depending on your path through spacetime. This concept forms the foundation for many other theories we'll explore. Einstein didn't just give us a new theory of gravity, he gave us a new reality to contemplate. To understand the cosmos, we must think about both where and when things are. Relativity transformed time from a simple parameter into a physical, malleable dimension. The universe is far stranger and more beautiful than we ever imagined. We all sense time moving forward, memories behind us, the future ahead. Yet most fundamental laws of physics work the same forwards and backwards. So why does time have a direction? The answer lies in entropy, a measure of disorder. The second law of thermodynamics says entropy always increases in a closed system. It's easy for a room to get messy, but hard to make it tidy again. The universe started in a low entropy state and has been getting messier ever since. This increase in entropy gives time its arrow. The past is ordered, the future is chaotic. You can't unscramble an egg because the universe naturally moves toward disorder. Our experience of time's flow is tied to this cosmic slide into chaos. The arrow of time isn't just an illusion, it's written into the universe's unfolding story. Entropy links our psychological sense of time to the fundamental laws of nature. The universe's history is a journey from order to disorder, and that journey is what we call time. Time's arrow is the universe's own history book, written in the language of entropy. What if the flow of time is just an illusion? Enter the block universe theory, or eternalism. Imagine the universe as a four-dimensional block, past, present, and future all equally real, existing together. Every event from the Big Bang to your next meal is a fixed point in this cosmic block. The present isn't special, it's just the slice your consciousness is experiencing. According to relativity, there's no universal now. Different observers can have different slices. The distinction between past, present, and future is subjective, not fundamental. If the future already exists, what about free will? In this view, your choices are part of the block, fixed by your actions. The universe doesn't happen, it simply is. We're not watching a movie unfold. We're experiencing one frame at a time from within the film reel. The block universe suggests reality is a static geometry, not a flowing river. Now, let's swing to the opposite view. Presentism. Presentism claims only the present moment is real. The past is gone. The future doesn't exist yet. Memories and fossils are just present traces. The past itself has ceased to exist. The future is a set of possibilities, not a reality waiting for us. Reality is created moment by moment, only the now truly exists. This view clashes with relativity, which denies a universal present. Presentists argue that physics may not capture the true nature of reality, only relationships between events. Despite challenges, presentism appeals to our intuition. The future feels open, and our choices matter. The universe, in this view, is a dynamic unfolding story. Each moment a fresh page. Only the page being written is real. Eternalism, the rival to presentism, is favored by many physicists because it fits with relativity. Time is just another dimension. Like space, all points in time exist simultaneously. Your birth, this moment, and your death are all equally real points on your timeline. Under eternalism, things don't come into being or pass away. They simply are. You are a four-dimensional space-time worm, stretching from birth to death. Change is just your consciousness moving along this worm. There's no need for a privileged present. All moments are equally real. This static, geometric view matches our best physical theories. Eternalism challenges our sense of agency, but our choices still shape the future. They're just part of the block. In this universe, being is more fundamental than becoming. Let's shrink to the quantum realm, where time gets even stranger. In quantum gravity, time can vanish from the equations, suggesting it may not be fundamental. Some physicists think time is emergent, arising from a deeper, timeless reality. Quantum entanglement might give rise to our experience of time's flow. Measurement in quantum mechanics introduces its own arrow of time. Once you observe a system, you can't unmeasure it. This irreversibility could be another source of time's direction. The quantum world hints that time might be granular, not smooth. Our classical sense of steady ticking may be an illusion, masking a much stranger reality. What if the river of time is made of quantum droplets? The quantum realm forces us to rethink everything we know about time. What if time is just a construct of our minds? Some argue that our brains create the experience of flow by linking static snapshots into a narrative. The feeling of past is memory. The future is anticipation. Neither exists independently. Our perception of time is subjective. It speeds up or slows down depending on our state of mind. Neuroscience shows there's no single brain clock. Timing is distributed and easily distorted. We don't perceive time, we construct it. The order and duration of events are part of a mental model. Physics shows clocks tick and elements decay, but the of time's passage may be an illusion. Change is real, but the river of time we feel may be a story our minds tell about a timeless reality. Is time's flow a trick of consciousness? To unite relativity and quantum mechanics, physicists developed loop quantum gravity, LQG. LQG suggests spacetime isn't smooth but made of discrete, indivisible units, like pixels on a screen. These spin networks are the atoms of space, you can't zoom in further. Time too is quantized, it ticks in tiny jumps, not a smooth flow. The smallest unit is the Planck time. Nothing happens in a shorter interval. Reality has a fundamental frame rate. This granularity could resolve deep problems, like the singularity at a black hole's center. The Big Bang might have been a big bounce, not a beginning from nothing. LQG paints a universe built on a cosmic grid, unfolding one quantum leap at a time. The smooth river of time we experience is a macroscopic illusion. At the deepest level, reality is a dynamic, quantized dance. Time is not continuous, it's a series of fundamental ticks. Time travel, science fiction or science fact? Einstein's relativity allows for time dilation. Travel near light speed and you leap into the future. This is real and measured, but it's one way, no coming back. Traveling to the past is trickier, full of paradoxes like the grandfather paradox. Theoretical loopholes exist. Wormholes could connect different points in time but require exotic matter we've never seen. Some physicists propose the universe prevents paradoxes, or that time travel creates parallel universes. For now, time travel remains a theoretical playground. Our understanding of time pushes the boundaries of imagination. The laws of physics don't rule it out, but reality may have the final say. Time travel reminds us how mysterious time truly is. The arrow of time is deeply tied to the second law of thermodynamics: entropy always increases. Heat spreads, order decays, and the universe slides toward disorder. The past is where entropy was lower, the future is where it's higher. Memory itself increases entropy, every thought and action adds to the cosmic disorder. The universe began in a highly ordered, low-entropy state, the ultimate source of time's arrow. If the universe started in chaos, there'd be no processes, no life, no time. Our perception of time depends on this special beginning. We live in a privileged era, surfing the wave of increasing entropy. Thermodynamic time explains why events unfold and why we remember the past, not the future. Time is the universe's journey from order to disorder. So, what is time? Is it a dimension, an illusion, a quantum tick, or the universe's slide into disorder? Each theory offers a unique lens on reality, but the mystery endures. The quest to understand time pushes the limits of science and imagination. Time governs every moment of our lives yet remains elusive. The simplest questions lead us to the edge of what we know. Our understanding is far from complete, and the future holds even more surprises. Which theory resonates with you? Share your thoughts in the comments. Thanks for joining this journey. Keep questioning and keep looking up. Subscribe, like, and comment for more amazing science videos. Your support helps us explore the mysteries of the universe together. Don't miss out, hit that bell and stay curious.